Engines hum the future's tune, rising fast beneath the moon. No more trails of smoke and gloom. Wings of change, they cut the air. Hydrogen dreams everywhere, flying clean without a care. Feel the lift, feel the flow. Up we rise, where dreams go. High sky, hydrogen, let's go. Let's fly, no carbon clouds, no smoke in the sky. Sky high, hydrogen, the future is clear. Clean air above, the world is here.
Good morning, good afternoon, and evening, everybody. Thank you for joining us on this President's Day and Family Day. I just learned about Family Day about 5 minutes ago. We are so excited to have you here. This Today's HYSKY Monthly may not go quite as long as our other ones, since it is a holiday for many of us. Go ahead and put in the chat where you're joining us from. And for those of you that are new to HYSKY or HYSKY Monthly, HYSKY Society is a nonprofit that is focused on advancing I can't talk this morning, advancing hydrogen aviation and decarbonizing aviation and aerospace through the use of hydrogen. We have many programs, including HYSKY Monthly, which is what you're at right now. And I invite you, if you're not already a member of HYSKY Connect, to join us over there. It's free to create an account. I'll put the link in the chat. And it's a great place to network, find your people, find recordings, webinars, etc. So you'll find all of that. Let's see, upcoming, we have Verticon is coming up in March. We're currently hosting the hydrogen safety for aviation course. This is the last week of that course. If you are interested in that course, you can find out what I'm talking about in the link that I just put in the chat. And before I introduce our speaker, is there anybody that would like to share a couple of announcements or events or things that they think the community should be aware of? I know, Mike, I'm not going to call on you to talk, don't worry. But if you want me to talk about any events, you could put them in the chat and I can talk to them, or somebody else can talk about them. Palm Beach, I love it. North Carolina, heading to Virginia, Charlottesville, Virginia, Connecticut, Philadelphia, Houston. We got people from all over in here. I'm curious, what did you all think about the HYSKY theme song that was obviously made with AI? I kind of like it. I stopped it before it went into a full-on rave, but it's a good way to get energized and excited, I think, in the morning on this Monday before we get serious and talk hydrogen aviation. Awesome. Seattle. I love it. That's great. And I do see, oops, I accidentally asked somebody to unmute. That was an accident. I didn't mean to click that, but I do see a lot of, I see a lot of new faces here. So I want to quickly just share my screen and show you all what HYSKY Connect is. And I encourage you to click the link that I put in the chat. And if you don't see the link, you can simply just go to connect.hysky.org. But these are all of the people that you can connect with for free in here. You can find all of our past HYSKY monthly recordings and videos. We have a VIP. Here are the courses that we offer. There are just loads of great resources in here. So I encourage you, not a lot of this stuff is free. So I encourage you um, to connect, create an account in HYSKY Connect. And so now I am going to have the honor of introducing our speaker today, our guest speaker. So I'm so excited to introduce Ryan Sookhoo. He is from EKPO and leveraging his techno-commercial mindset to drive the next energy transition. Ryan has over 20 years of experience in the hydrogen industry, specializing in driving business growth through strategic planning, market expansion, and sustainability initiatives. He's fortunate to have had the opportunity to be a part of some of the first of its kind hydrogen fuel cell adoption in the aerospace and the maritime sectors. As a global cross-functional leader, he is passionate about shaping new technology adoption through strategic partnerships and stakeholder engagement. Over his career, Ryan has been people-focused, mission-driven, and committed to advancing clean energy solutions. He started his career as an electrical engineering, I think that's supposed to say electrical engineer at Hydrogenics Accelera, leading the effort in achieving the first UL certified fuel cell module. Without further ado, ladies and gentlemen, please welcome Ryan Sookhoo to the stage. And I also should say that Bill Spellane, formerly with HYSKY Technologies, the one that connected us. So big shout out to Bill. Thank you for this connection. I'm very excited to see what EKP is up to. So without further ado, Ryan, the stage is all yours.
Great. Well, thank you so much, Danielle. It's exciting for me to be here when I think about how the years have passed and aviation. It really is a phenomenal time. So much is moving. I think this, it's only once in a lifetime that you're going to see this level of transition. When you look at what's happening in urban transit, with the various platforms from eVTOL to the more electric planes, it's just going to be the next stage, right? When we looked at how much the industry has also shifted over the years from hydrogen-focused vehicles, thinking there was a market primarily for mobility, and now there's stationary application. I think hydrogen will always continue to be a really strong solution when we look at having different ways of generating electricity, and in many ways a very low carbon footprint version. But for aviation, I'm super excited when I think about how much the technology, hydrogen fuel cell, have advanced over the years. And yeah, great shout out to my friend Bill. As I remember in the early days when we were looking at fuel cells for aviation, and just looking at all the challenges ahead, from putting the fuel cells, as I used to call it, on a diet, to getting the lifetime. Aviation sector has always been so focused on high reliability, as it's so critical, and just improving the technology where it's a viable option. And when I look at where the technology is today and what EKPO is doing, I'm even more confident that this will be the way, where hydrogen and hydrogen fuel cells will continue to play a big role in the future urban transit. For today's presentation, what I'm going to do is just highlight all the natural synergies which come across in various applications in fuel cells, and how we're using that synergy at EKPO to bring along the technology as a viable option for aviation through our engagement in the industry, but also our investment towards fuel cells as an option for aviation. And those investments mean advancing the technologies from performance metrics that actually make sense for aviation. So for today, I'm just going to give you an overview of EKPO because I think it's really good to when you hear presentations to understand the DNA of those companies and what drives them, and but also what are the offerings that they're using today that they can leverage the learning. Right, it's not about repeating mistakes, but building off of success. And our portfolio is a big part of that. And you'll see from the progression of the technology, and you'll feel that excitement that I'm trying to tell you about how much the technology has changed over the years, and in what key aspects. I'll also highlight that the applications that we work on is more about bringing along the hydrogen economy, and finding ways to leverage those different applications to focus on costs and availability of the product, where we're not only looking at one singular market and trying to figure out, why can't we leverage out volume initiatives to share the cost savings across it. And then we'll also give you like a highlight of what we think could really be exciting about some of our latest unit, and why we think it's actually progressing to be a very viable option for the aviation application. So EKPO, in the name itself, kind of highlights the parent company. We're a joint venture between ElringKlinger and OP Mobility. So the EK comes from ElringKlinger, and the PO used to be what OP Mobility was called. They used to be called Plastic Omnium, and that's where the PO was. They had a few years ago rebranded to OP Mobility. We have not made the decision to change our name, but because of how strong the parent companies are, both ElringKlinger and OP Mobility are very strong industry suppliers in the automotive field. So there is this very core understanding of volume, but also quality, right? How do we build repeatable unit at a high level? And ElringKlinger has been working on fuel cells and hydrogen technology and components for over 25 years, and pulling that technology along to fit these end application needs. And that ranges in various level of collaboration. When you think about EKPO, our mission is essentially to partner with the industry, which means the way we work with the industry changes. Sometimes we're supplying fuel cells, sometimes we're supplying components that go into other people's fuel cells. And in other areas, we're actually working with the industry to leverage volume manufacturing through design, plate fabrication, because our parent companies do a lot of high volume production, which means some of the cost savings and expertise and know-how that they do, we leverage. So it really means a ultimate benefit to the fuel cell industry, because we're not singular. We're really looking at addressing it as an industry, as a partner. EKPO is headquarters in Germany in an area called Dettingen. And if you're not familiar with Dettingen, that's okay. It is essentially just outside a 30-minute drive from a place called Stuttgart. I'm sure you guys would have heard of Stuttgart. Stuttgart is the home of Porsche. So if you ever get a chance, you can actually go to the Porsche factory and do an amazing tour. But EKPO is the complete stack building mass manufacturing facilities located in Germany. And there's roughly just over 220 plus employees there. We're continuing to scale to essentially build into those key markets that we're talking about. And this facility was established in 2021. I'm going to show you some amazing videos about it. I think you would be quite impressed by the investment we've made in terms of bringing that mass manufacturing and high level of quality into the fuel cell application. When we stare into the product offering of EKPO, It's really about addressing the markets that are moving today while leveraging our core technology. So I'll start out with the unit on the left, the NM5. This unit was designed with modularity into it, and it was looking at applications where the power node may not be that high, above 30 kilowatt or even 15 kilowatt. But there were applications such as material handling, potentials for even drones, where this lower power node, and this really is a sweet spot around this 15 kilowatt node, that the architecture that we had as a fuel cell had great value. Because at 15 kilowatt, all of our fuel cells are liquid cooled. So once you start to drop below that 15 kilowatt node, you start looking at other technologies such as air cooled fuel cell. So we made the determination that at this power node, having modularity and enabling our partner to scale as their business needs grew by putting multiple of these units together. We have the ability also on our stack side to put it together to essentially act as a partner. So we don't make full systems in the sense of a complete power module with all of the balance of plant. We work with our partners to basically understand, are they at the stage where they want us to contribute a little bit more on the balance of plant or the fuel cell? And we'll get into how that relationship varies with EKPO, because that's a big part of our DNA. When you look at the NM12 unit, this was targeting more of those higher power node that was really sought after, I would say 10 years ago, such as buses and a medium duty vehicle. It was around this 90 to 100 kilowatt where we saw a lot of growth potential. And our excitement was about bringing along a next generation of fuel cells to meet that need. So you'll see a significant increase in power density, even the gravimetric density, as we brought forth this new platform, the NM12. And in our intent on that was just to, again, scaling the technology by making it lighter, producing greater power. But at the end of the day, it was packaging it for the market. And that for us was a really good node, because it helped us to see that as we scaled the technology and brought in these improvements, we were also able to increase the durability. So transitioning from an 8,000 hour end of life product to a 10,000 hour plus. And then at the same time, we saw this growing market for higher power needs, such as eVTOL coming along, and heavy duty truck and backup power asking for hundreds of kilowatts. So our thought process at the time was, how could we further improve on the NM12? And we made the NM12 twin. And you'll notice that the power essentially doubled, but more importantly, the durability went up as we looked deeper at our architecture to see how could we leverage out even more out of the learnings and advancement of the fuel cell. Where we are today is quite amazing, actually. Today, we have released a unit in what we call a sample stage, which is essentially a second level of prototype, which means it's able to go out to market to key customers for their trial. So we're shipping it, and it's 400 kilowatts. And what's really exciting about this unit is, if you look at the timestamp of how the technology has been progressing, it's really impressive. So within 4 years, we were able to double the power. We were also able to significantly increase the weight ratio, the gravimetric. It went up to 5. And we also did something really, which I think it's industry leading. And it doesn't always shine when you talk to fuel cell companies. It's the operating temperature. You'll notice that the operating temperature has gone up to 95 Celsius, which is quite impressive for a PEM fuel cell. This is the continuous operating temperature. And why that's important is that temperature, the higher it is, the smaller is your cooling system needed on aviation, which means you're lighter. Your overall power production is extremely lighter. And we're also trying to push it even further to go above 100 Celsius. So why does that stand out for us is because we're ultimately making the complete power solution. And this talks to the eVTOL or aviation market much less in weight sensitivity. So it's completely lighter, smaller radiator. You don't you a fuel cell is getting closer and closer to that hotter running market, if you will, of the traditional combustion engine. So while holding this critical high temperature, we also significantly improved the stack life, which you would have thought should have been the drawback. That if I went hotter, theoretically, then that would impact the stack life. But we were also able to actually improve that. And then the efficiency, being mindful that as these fuel cells run, they're becoming main power plant as the application grow. So having a sensitivity to the fuel consumption, because that's directly going to impact those operational costs, was a big part of our initiative. So this NM20 is scheduled to go into what we call B sample stage this year, which is essentially 95% of what the production unit performance will be. And we're continuing to improve on it based on the feedback. So we're really excited about this new platform, the NM20. Uh, when you look into EKPO's DNA, at the end of the day, I think I said our mission is to partner with the industry, and that means being flexible on how we engage with our partner. So there isn't a one way only to work with us. We recognize that we're making the investment also in the technology, but our partners are making sizable investment in building the systems. So there has to be great values for them. And our strength is really around the stack and what I would call critical balance of plant supply, meaning those key components that are needed to run the stack efficiently and get you the best performance possible. So traditionally from EKPO, you will get a stack, which is this blue area that you see here that's highlighted as stack module. And that comes with the enclosure, it comes with the cells, and it comes with all the required uh, sensors needed to monitor the stack. But what we don't do is we actually do not supply like the coolant pump because those things, back from the integration days are very sensitive to the application, where you put a pump, how to service it, how to prime the cooling system. All of that learning, we realize it's better to have our partners take care of that part. Um, and that includes the anode recirculation loop, which is quite important for a fuel cell operation. But it's for the same reasons that we believe that these serviceable parts should be strategically placed and optimized for the application. Because if we included a pump that was, for example, heavy, that might have an ultimately very negative impact on your system. Or if we included a pump that had a low service life, again, it would not align with your maintenance schedule for your overall vehicle. So that white area that you see are the components which we spec and let you know what it is the operating condition needs to be. But we really strongly feel that is more application driven, especially stuff like your voltage conversion. What inverters you use, DC to DC. In aviation, as you know, your voltage is quite unique compared to, say, traditional land-based technology. So I do feel this strategy is quite important because we're not oversupplying equipment that doesn't bring a lot of value. And the last one I wanted to highlight was the ECU. For us, that is a very important one that we let our partners develop the code to run the stack. And that's largely about driving value for our partners. There's a lot of IP that is generated in integrating fuel cells and operating them and regulating them across the power band and performance. And we think that investment, because of our partners' ability and what they put forward to integrate these fuel cells properly, that IP should remain with those partners because that really is their secret sauce. So this is why we took this strategy of when we partner with the industry, we are completely flexible on how that scope of supply is, and we work with our partners to address all of these areas. It's not like in a situation where we throw it over the fence and say, "Hey, that's you, that's in the white." No, we will share our learnings. We will help in pointing you in the right direction, because we ultimately want you to succeed. And then from a fully integrated system, as you guys well know, it includes all the things in the green, from hydrogen storage and control, safety, all these things, which I think is well understood. But all of these layers add into making an optimal system. Uh, for this part of the presentation, I wanted to highlight the video because I think it's really important for you guys to feel how real this market has pulled forward and the investment made. If you ever have a chance to come to our headquarters, we would be happy to host you, for you to see the fully automated lines operating. As you walk through our massive facility, you will feel the production element around it. It's not a prototyping um, shop kind of feel. It's when you go through it, you feel that element of production level and high quality, like repeated volume initiative. And we made this initiative for this an investment in this facility because we also want to drive down the cost, right? We want to show that making the step into mass production, while pulling along the technology is our role, to basically give you a high performance unit with the lowest possible price. And as we talked about, our parent companies are very large in mass manufacturing, so we're able to leverage out their learnings, their buying power to basically bring all that benefit to the fuel cell market. So hopefully this video comes through, but it's essentially fully automated, this facility. And as you can see, the lines with all of the laser checking, the plates are inspected, built, seals are added, compressed fit, welded together, and they're also cleaned throughout. So you would think that as you go through this facility that these fuel cells are being produced at tens of thousands a year, because of the scale of investment and quality that we put forward. And as you saw, the molding and seal, these are critical parts of the fuel cell's durability, and that's why we automated it to remove any possibility of quality issues that would be down the line. All right, and then we took that same level of investment from a component stage of production and quality. We put it into the stack assembly. So all our stacks build is fully automated. And in order for you to get access to the stack room, you would essentially have to go through about 3 clean rooms. So high level, high focus on automation and high focus on quality, as we are trying to show this repeatable level needed. And I think that's a really big story when you're looking at aviation and wanting a high quality behind the products that you're engaged in, so that you feel it's completely repeatable, and the performance is the same all the time. Today, we use a lot of traditional application to continue to field test and gather data. I mean, our hope is that these things will continue to mature as markets and grow into sustainable business units. But at the end of the day, we think they're absolutely worth supporting, because it brings forward the technology to the aviation industry. We work with in the rail industry because of the high demand and utilization, vibration, impact. That all gets translated and we validate our unit architecture and design. It's a high uptime application. So the impact on life utilization, efficiency of the fuel, those are all validated through that application. And in aviation, you'll see two application with ZEP solution at the bottom. I think, from the early days of me working in the aviation side, um, ground support equipment was absolutely critical about introducing hydrogen to the ecosystem. And I think this needs to continue. We can't just focus on the end application. It's the safety around the fuel, the acceptance of the fuel at airports is also critical, or even in the space. And I think ground support equipment offers that initial step to bring hydrogen into the ecosystem. And then it also gives the opportunity to use the fuel cells in applications that benefit from them with a low emission or zero emission application. Again, showcasing that hydrogen as a molecule offers a lot of benefit. When we look to, well, how do we generate scale? Because that's needed to help us address our costs. As we made the investment in a mass manufacturing facility, we have to keep a line of sight also still to the what I would call the automotive or mobility application, a traditional land-based, because that will help with the purchasing power of the base material. It would also help with the fabrication. In aviation, we can align on certain form factors of those fuel cell design to benefit from that volume market. So that's why we keep this interest in driving this application, and the durability of these applications. They're high run hours, so that information also gets translated through and fed back into engineering, because at the end of the day, we're trying to build the most robust application. When we look to what we're doing in aviation, I think it's quite impressive, right? Um, as some of you might be aware, there is a program inside of EKPO, which is a joint venture with Airbus, working on the aviation fuel cell stack technology needed for aerospace, and that program is leading to a lot of cutting edge applications and needs, as you know well, that aerospace criteria are much higher than anywhere else around the world. So can a fuel cell be designed to meet that target market? Absolutely. And we're doing it with in the AeroStack program. As EKPO, we're able to leverage out some of that learning where possible to bring to others, right? So when I see it and I see the application we're doing with companies like Beyond Aero and the Long Range Aviation, Green GT, what we're trying to show is we can leverage learnings from other programs to bring forth other markets. So when we see larger drones, eVTOL, we are confident as a company that our stack technology can absolutely work. We just need the partners to take it out, right, and take it into market, as our goal is to enable those partners. And this market will continue. I think you will continue to see EKPO playing a big role in these forward markets in the near term, and that's just because of how sound and I would say proven the stack technology is, that it's finally being recognized by aviation and being pulled into that market. And it, as you see, given that there's a core focus because of our aviation program within EKPO, as potential partners in this industry, you're not carrying that on your own, right? You're working with a company that has a high focus on aviation and bringing hydrogen to it. I wanted to highlight some of the application around the fuel cell, the NM20, and this information is obviously shared with you. We talk so well about the higher temperature focus, but be mindful about those gravimetric, as the system is designed to be fully integrated with the partner, right? So you'll see the connection points at the bottom, single point connection, as we basically manifold all of the key components needed that we touched on. But this is the future for us in terms of mass manufacturing around this platform. This is the NM20, which allows you to leverage out those cost benefit and high performance. So when you look at where could it go, at this power node, these units are able to be stackable. They can scale quite easily into the multi-megawatt. It can also be put into alternative design to be much lighter. So from an industrial application, the power nodes to the megawatt is quite feasible for us. The performance are there, but also for application that needs it to be lighter or so, there are opportunities to do that with this unit. And to show that that unit is just not a fake unit, so to speak, for lack of a better word, I wanted to showcase some actual data with you. And if you're not in the fuel cell industry, don't worry about it. But the key though is how the way to know how well a stack is running is to run it at its full potential, and then which means the highest power you can, and then look at the degradation or the instability in the cells. That tells you how sound the technology is. So if you saw the cells having weak points at the edges or in the middle, it basically highlights there to be a weakness in the stack performance. What I would like for you to take away from this slide is the stack is actually completely homogeneous, and which means the cell voltage is almost identical at full load. So everything is working well in harmony. And that's what's highlighted by the slide you see right now, is that we're able to produce the highest potential power of that stack while continuing a strong stack performance at the cellular level. That at the end of the day, you can actually get higher efficiency if you choose not to, as you can see from the slide, run it at its full power node. So yes, we're generating 57% efficiency at full power, but how often do you run your engine continuously at full power? It is a common practice in any industry to target the right level for that engine to give you efficiency and power production, right? It's a balance of multiple factors, and that is fully in the suite of view that you could see from the stack performance. When we talk about stack performance, yes, there's stability in the cells that the previous slide showed, but the key is the degradation, right? Like, can you actually achieve those run hours that you're saying? And that's what this slide is supposed to highlight to you guys is we recognize that these units are going to be in the field in very extreme temperature and extreme in the sub-zero. So for those that work in Celsius, that the minus 39 will come out, and for those in the Fahrenheit, I would say it's extremely cold. So at minus 39, the stack is able to run and maintain its performance, and we do continuous repeated winter cycling, and that's really critical, because if there's a weakness in the stack's ability to run at the sub-zero temperature or start up, the cells themselves will actually start to degrade much quicker. And that's what's highlighted by the less than 2 microvolts degradation. It's basically saying the stack is unimpeded by these thermal cycling and winter cycle. So there is a lack of worry, if you will, that can it handle this or not. And then why is that microvolt really important? That's the proof, right? When someone says to you on a slide, hey, I can get to 25,000 plus hours. It's this microvolt degradation that you're looking at. And this is actual data that we're showing with you guys today. Is you could see from the degradation chart at running this unit at various load cycles, so starts and stop cycle, up and down, which is much more strenuous on a stack. It's actually cycling it up and down, on off, versus keeping it at a uniform. The degradation is actually very, very small. So this is how we, with the actual data that we're actually saying to you guys, we see this exceeding 25,000 hours on this platform, while doing all the other things we mentioned, maintaining the cell stability, having the ability to withstand significant shock, and doing those really harsh thermal cycling. Zeroing in more on the supply that we do, there are certain components that we supply with our unit, and that's just to help with the integration. We do supply what we call a media unit, which is the black part at the bottom, and that comes with some of the critical parts like solenoids, pressure switches, only for the ease of integration and service, even the water separator, because we think these are things that are critical to the stack operation, which are not as important, if you will, driven by the end application, unless there's like a certification requirement around certain solenoids. And in those cases, we're able to work with you to say, yes, we could modify this unit to have those to comply with your overall unit. So we're trying to leverage out the integration aspect of making this simple while increasing reliability by saying these are the right parts to run the stack. And those other ones that I mentioned before are what you can supply as an integrator or a full system provider to benefit your own IP and core knowledge. So stretching out, and I do want to leave some time for us to chat. Where could we take this platform? And we're quite confident that on this NM20 platform, if we were to push it further, we can actually get a platform that is 600 kilowatt. And the reason I'm saying 600 and you might be seeing 300 on the slide is in each NM20, there are actually two cells or two stack that make up that unit. We have a line of sight with high confidence that we can now push that cell, that stack to 300 kilowatts. So each of those two stacks can go from 200 kilowatt to 300 kilowatts. So a new NM20, if you will, with this new technology can be 600 kilowatt rated. And that just means much more power while minimizing the weight aspects, right? And that's super critical for aviation, as you know. And we're starting to put this technology out there in various market. I think from the weight benefit, we see this as today technology. We do have the ability through our internal development program that I referenced and expertise in titanium. So titanium as a base material inside the stack plate, it's very limited by customers who ask for it because it is a higher cost versus the traditional plate material. And then we see if we were to use titanium for, say, an aviation application, it could quite significantly improve that gravimetric. So when we combine all these factors, we think the NM20 is a great starting point when you look deeper into aviation and what could be achieved. And I have yet to see others on the market trying, as a stack company, trying to genuinely bring something forward with this level of performance and expertise. I appreciate the opportunity as always. Aviation's always been a passion for me. And I thank you guys for the time and look forward to any questions you might have. The material will be shared, as I said, and I'm happy to take any questions. Thank you.
Thanks so much, Ryan. Fantastic job. I'll start us off with a couple of questions to kind of warm us up, and I hope somebody else will feel free to come on and ask your question. Was that a picture of Beta Alea? And are you suggesting that EKPO is working on a fuel cell stack for Beta?
With respecting everyone, I would say we are in the industry without confirming too much, but we are quite confident that the material, the performance of the stack is quite doable for eVTOL, as you can see. What we're trying to do, though, is partner with the industry, right? By saying, let's not reinvent the wheel too much. Is there enough there based on what you as a unique company is planning to do to keep the industry moving forward and not overcommit from an investment perspective? So basically, take you along with product.
Got it. My next question is that the kilowatt number 300 kilowatt and then 600 kilowatt, that is extremely competitive with some of the best batteries. And especially in the eVTOL space, I've always said that just prior to the presentation, I've said that the best configuration for VTOL or eVTOL would be batteries for vertical takeoff and landing, and then fuel cells for cruise. Do you agree with that, or would you say now this you wouldn't even need that battery for your vertical takeoff?
Wow. So this question absolutely is driven by the applications, right? So the
Mm-hmm.
answer is unique to eVTOL. As you guys know, as an industry, the most amount of energy you use is takeoff, right? So your
Yep.
weight is really the anchor, so to speak. So if you have a high power fuel cell, you could absolutely minimize that battery weight from an energy ratio, right? To say,
Mm-hmm.
hey, I need this battery more as a hybrid for peak power and not for lift, right? So yes,
Mm-hmm.
so at 600 kilowatt, you would have a much more favorable power ratio to weight. And then, yeah, I do think you will likely always have a battery. I think there's a really good synergy between fuel cell and battery when hybridized. The
Mm-hmm.
and the value to any company, and this is where we're big on that company keeping the IP, is about that hybridization, right? And the
Mm-hmm.
control scheme. So yeah, so we're excited about that 600 kilowatt potential. We're also mindful that there are components downstream for voltage, right?
Mm-hmm.
And maybe those might be impacted. So we're not saying it has to be that,
Mm-hmm.
but if you had power electronics that were sensitive to a certain input voltage, you now have the ability to scale it back, right? So think of it as
Mm-hmm.
a sliding rule that you can bring the cells up to that much if you want.
Interesting. Very exciting. Okay, one more question, and then we'll let some people from our audience. Can you share whether or not you've your system or systems, your packs have flown on any aircraft? Can you share how many or any specifics around that?
Yeah, I think the success stories highlight where we are closest to aviation. I am not
Hmm.
versed if they've actually done it yet, but
Okay.
we could definitely follow up. Those are all public programs.
Hmm.
We're happy to share and let you guys know which one have actually been there. I will say though, there's a high confidence in the system because of our JV with Airbus.
Hmm.
And that is, I think, really unique to EKPO in this industry to know that there is a bigger program going on, and that is being leveraged to help the market, not necessarily taking any IP from that. It's
Right.
just what is the learnings, that whole safety aspect. It's into the DNA, and I think that's a really good value.
Yeah, I agree. It is great to see an OEM, one of the two, um, involved in this space. Okay, first hand I saw go up with Albert. So Albert, please ask your question, and then after Albert, Sarah, you'll be able to go, and then after Sarah, we'll have Doug. Albert, feel free to ask your question.
Yeah. Hi, Ryan. Very nice presentation. I was going in and out of it, so I might have missed really some of your points. Do you have a comparison of your fuel cells for non-aviation transport versus aviation transport? I'm trying to get a sense of how will the stack be different in terms of uh, power per unit weight. Uh, of course, material, you mentioned titanium at the end, but I don't know if you got to that yet.
Yeah. No, Albert, nice to meet you. For sure. When you go through the material, there is a slide that I spent on the product offering. I would say the specs that are listed for the NM20 on that slide, it was around the middle, is what is non-aviation, right? This is what we put out in the market today. It is a heavy stack from the perspective of we include the enclosure. The enclosure is not a requirement, for example. But if I was to put that stack into a truck, that enclosure is needed from the IP, the moisture rating, right? So the ingress. So I would say if you wanted to look at that unit as an aviation potential, it will be even better if I took off the enclosure. But at least you could say that is a non-aviation stack, right? Baseline. And then that might be good enough for certain applications in aviation. And then if you said, no, I need to actually go much further and lighter, that last slide is the potential of what if we were to change those plates over to titanium? And what if we were to grow the cells that is capable, right? Then you now get into what can an aviation performance level look like. Today we do not build that option. The market just doesn't have a big enough demand, and to be frank with you, the current NM20 without the enclosure is really competitive today with what others are doing. But if someone was to say, I do want to get tap into the full potential, and that's where we get more into product versus prototype. And it depends on where the company's at.
Okay. And on that point, is 7 kilowatt per kilogram really the target for the aviation or what?
That's what we're seeing possible with ours. We think we'll probably beat it. We're German DNA, so we're extremely conservative. If I could bring in some of my North American background, I would say there's a high probability we'll be better than that.
Thank you.
You're welcome.
Great questions. Next up, Sarah, would you like to come on and ask your question?
Yes, yeah, I wanted to know if you guys are looking for prospective beta testers, customers. Are you interested in a flying car as a potential beta tester?
Yeah, I would say absolutely. Like that's the DNA of the company. A bunch of engineers just made a really, really solid technology. We want testers. We want people to test that temperature benefit, right? Things that normally don't get called out at a system level. But from my background, I know temperature and a cooling system is for a fuel cell has always been like an anchor, right? It's unnecessary weight, and anything you can do to slim that down, not just improving on the stack. So yeah, we would love to engage with anyone who wants to look deeper at it. We're really comfortable. Like a lot of fuel cell companies will say, "Hey, that aviation stuff, I don't know about it," but I would say that's not EKPO. We want to be a main partner in that industry.
Thank you. Next up, Doug. Doug, I haven't seen you in a while. Welcome.
Yeah, I kind of got caught up in some other project work, but I had a question. This one involves the catalyst. I worked for a company a couple of years ago that they had small amount of investment money, and they didn't really have an idea that until it was too late that the platinum catalyst on their device would take up 2/3 of their investment money. So I was thinking to ask about that. Have you guys looked at non-platinum catalyst to keep the cost down? Because once you go to platinum plates for the stack, once you go to titanium plates for the stack, the platinum catalyst is still a big cost. So, the cost is going to go way up. I just thought, is that a concern right now? Are you trying to find a non-platinum catalyst?
So mission one right now is reaching the performance target. I would say most of our partner, Doug, are performance driven, usually by power, weight, temperature, size. We, as a partner long term with them, have to have a target for costs. So we always look at this. Once we get through to the baseline performance and said, okay, this is how we could do it with what we know today. Yeah, because we fabricate our own plates, we're able to truly tap into what is the realm of possibility, right? Where could we make a reduction? I encourage you, if you ever go to our facility, you would probably say, why are there 25 test stands continuously running? And we're always doing various tests from the thermal cycling, platinum loading, like you said, even testing out different membranes, configurations. So it's not done per se. It's just when we put it into a beta or a B sample level, we're offering to the market that this is going to be the spec we will maintain. And what we do, Doug, is behind the scenes, we're always trying to figure out how do we optimize on our costs, because at the end of the day, that's a big problem for the fuel cell market, right? Is bringing the price down. But we have to have that baseline target on the performance first to say, not at a compromise to this.
Okay, thank you.
Another great question. As I mentioned at the beginning of the webinar, we will get done early today, so I'll target 5 minutes from now. So if you do have a question, ask it soon. Do you have another question, Albert?
No, I'm fine, thank you.
Okay, your camera was on. Let me just mute it. Oops. I may have accidentally muted somebody that was wanting to speak, so if I did, forgive me. I'll ask a question. If you have another one, feel free to unmute.
Sorry, Day. I saw Richard messaging.
Richard. Okay. Oh, yeah, Richard. Come on. Hi, Richard. Good to see you.
Hi, good to see you all. And Ryan, thank you so much for sharing the EKPO presentation and pushing the boundary of fuel cell technology. Quick question regarding the NM20. So you stated that the spec is operating temperature of 95 degrees Celsius. Based on that temperature, I'm guessing it's still PFSA membrane range.
I don't know, Richard. I'm an electrical engineer, but I feel free to. My contact's there. We have no issue sharing with you that information. Feel free to reach out.
Yeah, I'm very curious. How you were able to achieve such a long durability at that operating temperature. So I'd love to find it. I'd like to learn.
Yeah. Like that's why, like from years in the industry, everyone plateaued at 85, right, across the board, the entire. And when I joined EKPO, I was shocked that 95 was where they were already at. And the product range is that 100C. That's why we're not shying to put it on there, because we have such positive results that we do believe that to be quite feasible as we continue the product development.
Great. Thank you so much.
If somebody else wants to go, we have 3 more minutes, so you don't even need to ask. You could just come on and interrupt me. I'll ask this with our remaining 3 minutes if nobody else goes. So you're in Canada, but your headquarters are in Germany. Do you have operations in the United States? And whether you do or not, what do you kind of see the market doing in the US? What are your thoughts just around administration and different headlines with companies and things like that? What are you kind of thinking?
So I will say so my head office is Fort Wayne, Indiana. So EKPO does have a facility, a fairly large facility in Fort Wayne. The objective is to basically leverage that up. So we've made that investment, looking to the market to say, hey, if we could get enough volume, just like we did in Germany, we're happy to put up the millions of dollars to bring that automation to the US. I would say right now we're definitely in a pause phase, given how much things have changed in the US. So unfortunately, it's not a positive story like, oh, we're going to scale it. Right now, we're worried that we might have overcommitted a little bit if the market continues this way. So we're reviewing it. And I actively come to the US. It's just my family are like really big on Toronto. So I said, okay, no issues. But I love the spirit and activity in the US. I've done many years trying to help spur that on. So my thoughts are, Daniel, is if the market demand is there, we will invest further. But it's just right now, it's there's a lot of moving pieces, and we're just kind of reviewing it.
Yeah, well, I would love to chat more on that. We're putting together a letter Anyway, on Wednesdays we meet for a networking thing, but I would just really encourage you to get involved with our, I think we're just calling it an advocacy group for now, but that's something that HYSKY wants to do as a nonprofit, is to advance the industry in the US and in North America, but especially right now the US, because of, kind of the, I guess, shaky things that we're seeing. So I encourage you, I'll follow up with you on that as well, how you can get involved. All right, we're at 11:30. So I'm going to let you all get back to Family Day and President's Day. Huge thank you to EKPO and to you, Ryan. Thank you so much. This presentation will be ready on YouTube later today, and you can also find the slides in the video in HYSKY Connect. So thank you again. It was a wonderful presentation, very exciting. Thanks. Have a good day, everyone.